Microbes proliferate with astonishing speed, 1 million times more rapidly than we humans. The rapidity of their growth has far-reaching consequences because it allows new genetic variants to expand their population immensely in brief periods of time. Thus, antibiotic resistance can emerge to dominate a population of bacteria in short order from very modest, even undetectable beginnings. And by the same token, microbes can vary in ways that allow the immune response to be eluded. Think of influenza. Many of you will immediately recall the continuing change of the influenza virus, which necessitates the preparations of new vaccines almost every new flu season, and you will hear more of this later in the week. The genetic instability of microbial populations has produced a stunning diversity. Modern techniques can detect as many 10,000 different types of bacteria in a single gram of soil. Estimates of the total number of bacterial species run as high as 10 million. Pasteur exploited this variation to isolate weakened or attenuated variants that had lost most, if not all, of their ability to cause disease, and these, he found, could be used as vaccines. In due course, the strategy of vaccination has been extended to many other ailments, becoming a major defense against infectious disease. Only hygiene and nutrition are its equals. Here's a modern perspective. 4 of the great pestilences of childhood, poliomyelitis, German measles, measles, and mumps, all virtually eradicated from the U.S. population by the use of artificial immunization. In each case, you see the arrows indicate the introduction of immunization. We had 2 different vaccines in the U.S. That's why there are 2 arrows. In each instance, the introduction of vaccination was followed by a virtual eradication of the problem. Now, regrettably, prophylaxis still fails because we are indulgent and careless, because our wits have failed us in some of our efforts to develop specific vaccines. You'll hear about that in HIV, I suspect. Malaria is another example. And because we fail to use vaccines in an equitable manner. So intervention in disease remains one of the hallmarks of the physician's dealings with microbial pathogens. The development of specific therapies for infectious diseases represents one of the great triumphs in all the history of medical science.
Quel pourrait être l'effet des organismes génétiquement modifiés sur les épidémies? So it's a question which I suspect can have many facets in its answers, some positive, some negative. What could be the effect of genetically modified organisms on epidemics?
I will try that one. Genetically modified organisms are very important to us for the future of our health systems. I'll demonstrate tomorrow night that it was necessary to use genetic modification to remake the 1918 Spanish influenza so we could understand the mechanism of virulence of that virus. Then we used the same mechanism to make a vaccine so that we're prepared for this bird flu. We had no other mechanisms for making the vaccine in preparation for the bird flu. So there are 2 sides to this coin. One, we can create pestilences, and on the other, we can have the future of controlling them. That's where we stand now, the plus and the minus of controlling infectious disease.